Okay, welcome everybody. We're restreaming on various social media platforms, LinkedIn, YouTube, and Facebook. Uh, I'm pretty sure. This is Lance Luke and Martin Pea, part of our ongoing webinar series, Ask the Building Expert. And we have an interesting topic today because there's a lot of misinformation or misunderstanding about engineers, and some people think there's only one engineer or one type, just like there's like one building code. So I'm going to briefly give you a rundown on the different types of engineers for construction projects. So let me go through some quick slides here. Okay, we're webinars presented by Construction Management Inspection, which is a Hawaii-based construction management company. We also do building and property inspections, expert witness testimony, mainly running various construction projects for the majority of clients are condominium associations. So types of engineers for your construction project. Now, before I get started, there's different types of engineers that aren't necessarily construction engineers. You probably heard of the term domestic engineer. Um, that's kind of a upgraded terminology for people who do house cleaning or stay at home and do housework and things like that. Also, years ago, there was a term sanitary engineer, and we knew that to be your garbage collectors, but that changed over time. There's actually other engineers, like, have you heard of locomotive engineers? Like people who operate the choo-choo trains in the old days, shoveling coal and burning coal. That's how the trains operated by the fuel was coal. And then also there's aerospace engineers, and the term for them is commonly in conversation called rocket scientists. Like, you don't have to be a rocket scientist to do this or that. Um, there's also in the medical field, biomedical engineers. In the IT field, there's computer engineers. Lately, because of AI, they've been called prompting engineers, which actually work on giving data to AI, ChatGPT, and OpenAI, and all that. And there's also traffic engineers that design roadways and freeways and things like that. But for today's discussion, we're going to be talking about engineers that pertain to construction or construction projects. So let's go right into it. There's different types of engineers, and you may heard of some, you may heard of all, or maybe you just heard of the term engineer. But there's what's called a geotechnical or soil engineer, and that's a study of the land, the ground, the characteristics of soil and rock, and how the earth was formed, volcanoes, and things like that. Very important because that's the first engineer actually that would be involved in a construction project. You don't want to build anything, uh, a house or a 40-story high-rise building or a 100-story high-rise building without knowing the soil conditions and what's beneath the soil. For instance, is there like a bad soil? Is the property located in an area where it's close to the ocean and there's coral, or uh, during high sea level, you're going to get things wet? Another type of engineer is a civil engineer that designs drainage conditions, designs bridges, and that kind of thing. And then there's structure engineers who design buildings, the structure of the building. Structural engineers also design bridges too. Sometimes they work with the civil engineer. So that's your basic ground, drainage, and foundation and superstructure, the structure of the whole building. And then what's inside the building, okay? You got electrical engineers that work on all your electrical wiring, your panel boxes, your distribution panels, your transformer, those kind of things. And then what else do we have? You have plumbing, right? You have plumbing, drain piping, supply piping. You also have air conditioning, HVAC system. All that is handled by the mechanical engineer. And then you have your fire protection, fire sprinklers, fire alarm system. Those are life safety requirements that is basically handled by a fire protection engineer. So these are the different types of engineers that we're talking about. Now, in a single family house, you could actually involve all of these engineers, and there's different other engineers that are also involved, but these are the main ones. So doesn't have to be a huge building, doesn't have to be a specific building like a commercial building, office building. So any type of building, it could be like a shopping center, office building, apartment building, a single family house, duplex, townhouse. Those types of projects all could involve one, two, or more, or maybe all of these different types of engineers. Now, if it's not a new construction project, if it's uh, a building that's built already and you have to fix one component, such as your concrete spalling, then you involve a structure engineer. If you deal with electrical, then that's your electrical engineer, and so forth. Okay, so there's also different other engineers, which maybe I'll briefly talk about that if it comes up. So geotechnical soil engineers, as I mentioned before, soil testing, very important. It doesn't matter what kind of building you're building. It could be one house. You want to know what the characteristics of the soil is, right? You don't want to build your house and then find out later the concrete slab is cracking or your house is sinking because no one ever bothered to test the soil. Okay, so that's why all these commercial buildings that are going up, all these high rises and low rises, when they build new, they have to do a soil test, because the structural engineer is going to say, I need information about the condition of the soil. How can I design the building if I don't know what the soil condition is? Otherwise, I'm just designing something, and what if there's a failure? So the structural engineer might get blamed if the building starts cracking and sinking. Okay, so it's always wise. Now, here's the takeaway. If you have an old house, let's say you have a lot and then you have an old house, and the old house is maybe 900 square feet, built in the 40s, and you're gonna knock that house down and you're gonna build a brand new house that's about 3,000 square feet. Just because that old house is there doesn't mean that you don't need a soil test. Okay. I was involved in a litigation case regarding that, and when the contractor got deposed in a deposition, the contractor said, I didn't need to do a soil test. I didn't think one was necessary because there was a house there before. But then a 900 square foot house, the weight of that house is different from a 3,000 square foot house, right? The old house is wood frame. The new house is CMU, block tile, and concrete. So there's a big difference in the weight, the load of the two different structures. So that was kind of dumb um, on the part of the contractor. The other thing was that um, the soil condition in that area, which was close to the mountain, was already bad. It was expensive soil. So knowing that there was expensive soil, that's even more so that they should have had a soil test done. Okay, so and that ended up costing pretty much half the cost to build the house, to fix the house. So it was not a good situation for the contractor. So a geotechnical or soil engineer. So the word geotechnical is a technical word for soil engineer. So if you want to sound smart, just say, "Oh, did you hire a geotechnical engineer?" Instead of saying, "Hey, you got one soil engineer hired." So, by the way, before I forget, I want to thank um, all those that tuned in on our social media platforms and our Zoom platform. I noticed that we have people from Hawaii, of course, where we're based, but from parts of the United States and even other parts of the world. And I just want to make it clear that the information that I'm providing to you today at this webinar applies to any type of construction project. It doesn't have to be in Hawaii. It doesn't have to be in the United States. It could be anywhere in the world. It could be in Japan, Italy, France, where else? UK, Portugal, Spain. Uh, all these same concepts apply. So it's not only United States provided information. And that's the good part about it, because when Martin and I present these webinars, it's not specific to a certain area that we're in. Okay? It applies to anywhere. So basically, you could you could take the contents of this webinar and have it apply to any situation. And I'm thinking um, some of it could even apply to construction that's outside of the Earth, maybe the moon or on Mars. I know there's plans to build uh, on on the moon and maybe on Mars. So, but I don't get into gravity situation, but it could be a little different. But for the most part, some of the same concepts apply. So, a geotechnical engineer uh, can help you design a retaining wall. Why? Because what kind of wall? How big is your wall? How high is your wall going to be? How much dirt is it going to be retaining? Is it going to be retaining a building or a house? So you want to know what the soil is, right? Based on the soil, the structure engineer would design the how big the footing is, how deep the footing, how wide the footing's going to be. So basically, when the wall's completed, you can't see the footing because it's underground. Now, properties that are on a hill or on a mountain, there's some slope stabilization, so the house or building doesn't slide down the hill, right? So the soil engineer will help specify what kind of design he recommends for the type of slope, the type of soil, what kind of rocks do you have? Is it really stable? Those kind of things. It's very important. Sometimes the geotechnical engineer might say, the soil's so bad, you have to excavate, take out so many yards of soil, bring in engineered fill, compact it, and now you're good to go. So it's not a situation where all the time you just test the soil and you design accordingly. Sometimes if the soil's so bad, you have to remove it first. And then the soil engineer is involved in the design of the foundation because you're digging into the soil and you're laying footing, concrete footing, or um, other types of footing if you're doing piling or that type. Okay? The condition of the soil is very important. Now, here's something. If the condition of the soil is not that good and you just, without testing, um, build a road, pave a road, okay, and then the road starts cracking and sinking. Why? Because the soil was bad. So you're wasting your money if you don't get all the information. So the idea here is you gather as much information, as much intel as you can about the lot, the condition of the lot, and so forth before you start designing anything, let alone building. Let's talk about a civil engineer. A civil engineer gets involved in what? Well, designing bridges, drainage situations, road and highway construction. That's a civil engineer. May involve also a traffic engineer. And then bridges, water and wastewater infrastructure, dams, that's civil engineering. And then also urban development. So civil engineers kind of comprise of partly soil engineering and structure engineering. And sometimes they wear many different hats. Okay. Structural engineers, it's pretty obvious. They handle the structural part of the building, the framework, foundation through up to the roof. They have to design, let's say they're designing a 40-story building. They have to be able to calculate the load on the roof all the way down to the foundation. Because if they don't, the building could start sinking or cracking or falling apart. So the structural engineer gets involved in the design of the building, okay, the superstructure. So if you take a building, and you look at a 40-story building and you remove all the windows and glass and all that, what do you have left? You basically have the frame, right? The frame of the building. And that's basically what the structural engineer is designing. But he also has to take into consideration you have all this glass and siding going on the building. How much does that weigh? And the higher you go, if you're going designing a seven to 10-story building, your wind load is not really a factor as compared to up high, 40 stories high or 100 stories high, right? So the building is actually swaying in the wind because the higher you go, the more forceful the wind is. Okay, so all that has to be taken into consideration. What is on the roof too? What kind of equipment's going to be on the roof? All these mechanical equipment, such as your air conditioning, the cooling tower, maybe um, your elevator, machine room, and then the building is designed to handle an elevator, right? So also the structure engineer gets involved in bridge construction. So both the civil and the structural have a part in the construction of a bridge. And here we have the famous Golden Gate Bridge. But did you know that in Portugal, there's a bridge that looks almost exactly like the San Francisco Golden Gate Bridge? And it's really interesting. And the idea, why? Because it was designed by the same architect. So that's why it's the same. And about three or 4 months ago, I actually walked on that bridge in Portugal. Because we have to cross over to go to this port place, and it wasn't port like on a dock in the water. It was port wine. So I went to this winery and we sampled wine tasting, port wine. And I don't drink, but when it comes to wine tasting, yeah, I'm not gonna miss out on that, right? And it was pretty good. And plus that, yeah, I like to get free wine, so that was uh, that was pretty cool. And then structural engineers get involved in rehabilitation. They get involved in, you take an older building and you want to fix it up, or you take a building that collapsed, right? Like uh, the several years ago, we had that building in Florida where the whole building basically collapsed, and that's structure engineering. In Hawaii, several months ago, we had a balcony or lanai wall, a railing wall that basically collapsed and fell down, 5 floors. That's part of structure engineering. Structure engineers have to be hired to figure out what happened, what was the cause of the failure, and how do we fix it? We got to come up with some kind of remedial fix. So, um, a big church like the Sagrada Familia in Barcelona, Spain, which I had the opportunity to inspect and visit about uh, 3 weeks ago. That was pretty amazing, and I didn't get to talk to any structure engineers, but I could see the work that they're doing, and it's to me it's harder designing and building a church like this versus a uh, 40-story high-rise building because your components are all different. How do you design the spire on the top of the church? And there's many of them. And how do you attach it to the church? And let's say if there's an earthquake, um, how do you make sure that that piece is not going to like crack, shake off, and all of a sudden fall down to the street? So, uh, by the way, I'm giving a special webinar on specifically in that church. And I'll tell you more about that uh, toward the end of my presentation. And then we have the electrical engineers. Without the electrical engineers, no one would know what kind of electrical components to put in the building, right? How many wires do we need? What kind of amperage? How we're going to get the power from the local utility to the building, and how much power do we actually need? And when you're designing a building, you have to over design it on the electrical. Why? Because you already know that people are gonna start plugging in all kinds of things that without even checking. So, for instance, an older condo was built in the 1960s, okay, or apartment building, and there was a 50 amp service to serve each unit. Okay? Now, remember, in the 60s, they didn't have these modern day disposals or hair dryers, and then people decided that, oh, during the summer it's hot, so I'm going to install a air conditioning system. Okay, was that unit or the building designed for air conditioner? No, it wasn't. Okay, so your main is 50 amps. That's all. And it was only designed to handle your major appliances, such as your stove, your cooktop, and your water heater. It wasn't designed for major appliances like an air conditioner or a disposal, or guess what? The common uh, question I get is, when we run our disposal or when we plug in the hair dryer and then we're in the bathroom and then the lights start dimming. Oh, okay, well, that's not a good sign. Or um, the person is upset because they came home from work and they think they're gonna have hot rice in the rice cooker before, because when they left in the morning, they turned it on, but somehow the circuit got overloaded and the rice never cooked. Okay, so they're wondering what's going on here, and they call me and I say, I need to know what the amperage is. How old is your building? What's the amperage? And then I tell them your building wasn't initially designed, your unit wasn't designed to handle your your air conditioner. What happened was they want a cool unit when they come home from work. So they leave their the window air conditioner on all day while they're at work. So when they come home, it's cool. But what happened is it overloaded the system, and then the outlet on the kitchen didn't work. Okay, so it tripped because it was on the same circuit. They got upset too because when they came home, their air conditioner wasn't working. So that's because it's an overload, right? I said, the circuit breakers are made to trip. And if they didn't trip, guess what? Your whole building could have burnt down because the a fire would have started at the breaker where it overheated. And so electrical engineers, very important. They make sure everything's safe, um, and don't go adding power strips and all these different wiring, even if there's a available outlet, you plug in a power strip and voila. Now I have 6 or 8 new outlets I can use, right? Especially during Christmas time. So electrical engineers get involved in PV or solar design, renewable energy projects, data center infrastructure, and of course, you're building electrical systems. Now, electrical engineers are involved in EV charging, designing EV charging stations, having it installed. Also, your not only PV, but what are the other types of renewable energy? You have these solar farms, and then you also have your windmills. Electrical engineers are involved in the windmill. Also, your structure engineer, because those windmills are so huge, they have to build the foundation accordingly. So when there's heavy wind, that whole thing doesn't come crashing down. Okay, so electrical engineering, very important. And then we have your mechanical engineers, which, most people, they're not aware of the mechanical systems in a building. You just, turn your faucet on, you get water, you flush your toilet, okay, everything works, but where does the water go? Who's in charge of designing all the piping and piping configuration? It's the mechanical engineers. So they get involved in designing your plumbing systems, right? Your hot water systems, your drainage. Where does the water go when you flush the toilet? That's the mechanical engineer. What happens if it gets hot? Well, you put in air conditioning. HVAC system design. They're involved in that. Okay. What does HVAC stand for? The H stands for heating. V is ventilation. AC is air conditioning. Okay. And then mechanical engineers also get involved in fire suppression systems such as fire sprinklers and wet and dry standpipes and those kind of components in a building for life safety. Now, the mechanical engineer works with the fire protection engineer on your fire suppression system and so forth. So let's talk about fire protection engineers. Most people don't even know that these engineers exist, right? Because it's a small niche. So a fire protection engineer is involved in life safety of a building. It doesn't matter what kind of building it is. Okay. Could be a house, it could be a office building, shopping center, high-rise apartment building, or high-rise condo. all that falls under the jurisdiction of the fire protection engineer. So we got fire detection and suppression systems. You got your smoke detector, smoke alarm, your fire extinguishers, your fire hoses, fire alarm system, fire sprinkler system. And then also they're involved in fireproofing. Now, fireproofing is a subject that the architect would also be involved in. And by the way, the architect is a separate category. The architect is not considered an engineer. And um, normally in a big construction project, the owner or developer hires an architect as the main person for the design and the design team. So your design consultants are considered your architect, which is the main guy, main company. And then under the architect normally hires all the engineering consultants, all the design consultants under that architect, such as I mentioned before, your geotechnical soils engineer, your civil engineer, structure engineer, electrical, mechanical, fire protection. All those engineers would normally fall under the umbrella of the architect under the architect's contract. That's your whole design team. And there's others, specialty. So fireproofing, the fire protection engineer would have a say in the type of building components that are going to be used in the building for fire safety. Now, I'm not sure if you guys remember, uh, in the UK in London, there's a high-rise building called the Grenfell Tower, and there was a major fire, and a lot of people died in the building because of the fire and smoke. And what happened was the cladding that was used, it was a retrofit. They had this cladding on the outside of the building where there was some foam insulation in it, and it wasn't fire resistant, so it caught on fire. So if you see the middle picture and see that blue siding cladding, okay, that's what I'm talking about. Okay, and then also, believe it or not, the fire protection engineer is involved in wildfire defense. Okay, that's part of what they do, and we've had uh, some major wildfires. I thought it was in California before, well, mostly, and then it spread to Oregon and Arizona and other states. And then, in our hometown, on the island of Maui in Lahaina, you heard of that bad wildfire that killed about 100 people. And so a fire protection engineer is involved in that also, writing specifications on how you're going to design your house or building to better withstand a wildfire, and then also, what to do about your landscaping. You don't want to plant trees so close to your house where if the tree catches on fire, next thing you know, your house is burning down. So that about sums it up. So the conclusion that I have is just be aware of the different types of engineers on a construction project, and know what their roles are. And normally, if you're the developer, you don't necessarily talk to each one. Um, you mainly talk to the project architect. Okay? So, and then what you miss, previously, we've given a whole bunch of webinars. It's on our website. I'll give you uh, the link in a little while. But we've given webinars on almost every single building and construction topic, from roofing, waterproofing, concrete spalling, drain piping, hurricane ties, and you name it. It's all on our website. all our webinars are recorded, and you can watch it on demand. You don't need a Amazon Prime or Netflix account, but you do need to provide your own snacks. Uh, but it's very informative. I say that if you watch one of our webinars you did not learn anything, then we didn't do a good job in educating you. But we like to educate. And what's coming up? We have a, a schedule of webinars we're giving, and let me give you a rundown of the schedule here. So uh, the next webinar we're going to be talking about is, oh, we just added this one for this month. When structures speak, the silent danger of overlook railings. Okay, I'll talk more about that. And then fire sprinklers, who needs it? And then we got another webinar we just added about the Sagrada Familia, that big church in Barcelona, Spain, a masterpiece of art and architecture. I'll talk more about that. Then top 10 costly condo renovation projects. And this is mainly a talk about common area projects. For instance, when a condo needs to be fixed, a condo building, what is a major projects that is normally prevalent? And it would be concrete spalling, painting, waterproofing, cast iron drain piping, elevators, that kind of thing. And then another webinar is construction terminology. Uh, what's this mumbo jumbo? I'm going to teach you construction terms. So when you talk to your contractor engineer, they think that you have a degree in construction or building. You're not fooled by, oh yeah, we're gonna install these sill plates, 16-inch on center, and then you're like, whoa, I don't even know what that means, right? So I'm gonna fill you in on construction terminology. And then the next webinar is history of major disasters in Hawaii. Talk about tsunami, volcano, hurricanes, that kind of thing. That's good. And then changing up a bit, giving a talk, webinar about smart condo management, uh, asset care, and legal insights. And that's getting into more condo real estate stuff. And then I have one on real estate. It's real estate 101, talking about licensing, ethics, and AI marketing. And I'm still kind of tweaking that one. Want to make sure that it appeals to the masses. So that railing webinar, we just decided to put it up on our schedule. So the topic is when structures speak, the silent danger of overlook railings. And what we'll be talking about is railing safety, recent incidents about railing, historical collapses, talking about some of the major ones that occurred in California and other parts of the US. And I may even have some different parts of the world. Preventive measures, engineering solutions, and standards and compliance. So that's all about railing. That's just a specific webinar about railing. And in July, I'm talking about Sagrada Familia, that big church in Barcelona, Spain. And, I went there to do some inspections and talk to people. And so I'll be talking about the architecture and history, details of design, the size, the dimensions, building permit issues, the progress, the phases and progress of construction, completion, and future plans, and also cultural and tourist impact. So uh, that's the only basically uh, high-rise structure in Barcelona that's old. You could see it from like miles away because it sticks out. So I'm kind of excited to present that. So let me see what else we have here. Here's our website, askbuildingexpert.now.site. Now, that's where our listing of all our webinars are. You can pick and choose which one you want to watch. We have our takeaways, a PowerPoint presentation, and then we also have other websites, expert websites that you can go to about different things, such as fire, life safety, building permits, contractor licensing, which only applies in Hawaii, by the way. Um, and there's a whole bunch of other websites you can visit. We have publications. So we have free books that you can download. They're available on sale at Amazon, but if you want to get it free, you can download it through our website. So that's our website, askbuildingexpert.now.site. Every day we're working on it, putting new information up to help you. And after this webinar is completed, we'll be putting up a recording of this so you can watch it later. So if you're not watching it on a live stream, you can also watch it on replay on the social media that you're on, or come to our website and take a look. So you got questions, I got answers. Lance Luke, 808-422-2132. That's my number. Although if you call, I might not answer right away. And then email lanceluke@hawaiibuildingexpert.com. By the way, this email works from anywhere in the world, so feel free to use it. Also, the phone number works from anywhere in the world also. So like to bring Martin back on, and I see him already. See if any questions or comments. Even if you don't have questions, if you have a comment, that's fine. Let us know. Also, if you have any ideas for future webinars, let us know. We'll be happy to consider them. We have a team that we discuss and decide on the webinar topic, see which ones are top of mind, which ones we get the most interest, and we don't mind presenting the topics that you're interested in. Also, I have a monthly newsletter that comes out. If you're interested in that, shoot me an email and we can put you on a mailing list. Right now, we have, I lost count, 6,500 people on our mailing list or something. You know, once you get it, you don't have to read it right away. You can save it and read it when you have time, but at least you get it. Also, if you're interested in a webinar topic, upcoming topic, if you go to our website and sign up, even if you can't attend live, we'll email you the replay. Okay, so that's a guarantee that you're still going to get it. So it's not like you missed out. You may have missed out live, but you still can get the replay. So you see how nice we are? So we're going to be even nicer when Martin asks me the questions that you've asked, and then hopefully I'll give you the right answer. So thank you for joining, and let's talk about question and answer time now. So
Yes,
Martin, are you ready?
yes, Lance, I know this is your favorite time, and we've had a couple of questions come in, so why don't I hit you with the first one? The question is, Lance, can you provide examples of real-world construction projects where the collaboration between different types of engineers played a pivotal role in the success of the project?
Okay, I'll give you an example. I worked on this $3 million single family house, okay, from scratch. It was a beachfront property, and we involved it was just a vacant lot, so we needed to do some soil testing. There was a lot of sand there. We involved the civil engineer for drainage, structure engineer who was a combination architect and structure engineer, which was a good thing because if I had any question, either architectural or structural, I'd just make one call or send one email. And then there was a mechanical engineer who helped design the mechanical system, air conditioning, and then the electrical engineer was involved. So all these engineers had a part in designing the house. Now, the engineers would spend a lot of time designing it, completing the plans. Once the plans are submitted for a building permit, the engineers aren't necessarily involved on a day-to-day basis, but only when we call them. So basically, um, the architect and structure engineer uh, were there a lot more than the mechanical or electrical engineer. Only when we had issues that came up or the contractor had questions on how to wire things, or this air conditioner doesn't fit in this space, then we would call that respective engineer to come out to the job site. But otherwise everyone's working together in harmony and making things happen. The main thing at the end was it became a successful project. It was finished, the owners got to move in and enjoy their new house. So that's an example of how everybody works together. I can give you examples of some people that necessarily didn't work together on a new condo building. The architect and structure engineer gets into an argument because the contractor's saying, I can't build it the way it's shown. And the architect says, well, I didn't design this foundation, it's the structure engineer. So there were words going back and forth, heated argument, and um, I have to call these people in because the contractor calls me. I was hired as a construction manager. So the contractor calls me and says, what do you want us to do? It doesn't fit. It doesn't work the way that it's designed. And it was pertaining to some load bearing column in the basement where there's parking, basement parking. And the engineer said, um, not a problem. Just make the column bigger. Okay, so you would think, all right, that's a solution, make it bigger, right? And so I get the email saying, um, according to the engineer, we're gonna make this column bigger, and then here's his latest design. We're gonna add a foot and a half to the entire column. And I'm saying, okay, well, that's a good idea. But then guess what? That guy's parking stall who parks next to that column, now he can't fit his car in because now the parking stall becomes a compact stall. And what if the guy buying the unit doesn't have a compact car, right? So, oh, it became a problem, right? So anyway, it got resolved. I think there was some extra room at the last parking stall. Um, so they had to kind of redesign the parking stalls. So it worked out, but it's not all hunky-dory, uh, smiles and everyone's having fun at a construction job site. It gets kind of hairy when things don't work and there's arguments and delays. So a delay could be very costly, because if the developer is borrowing money and he's paying, $50 to $100,000 a day in interest on the construction loan, he can't afford to be waiting 1 week, 2 weeks for a redesign and things like that. So the show must go on. So hopefully that answers the question. I can tell you more if the uh, person that asks has more questions. Just call me or email me. I can give you some more war stories.
Okay, Lance, thank you. That's yeah, there's always war stories, unfortunately, yeah. Okay, the next question that came in here is a person who says, I'm interested in the sustainability aspects of construction. How do environmental engineers fit into the picture? And what role do they play in ensuring that construction projects are environmentally friendly and adhere to green building standards?
Okay, so when you talk about green building standards, it's not like you paint the building green and you're all good to go, right? So let's talk about, like, this is one type of engineer I didn't talk about. So environmental engineering. So some examples of environmental engineering would be like designing dams or systems for recycling, reusing building waste in construction, or maybe a municipal water supply, wastewater. Some of that is mechanical engineering, sewage treatment plant, also designing plants. Have you heard of this? The military has been using it for a long time. Designing a plant or having a plant that you can convert ocean water to potable water for using to irrigate crops or even drinking. Okay, so uh, there's refineries reducing uh, pollution in the air from all these industrial uh, factories and all that. That comes under the jurisdiction of environmental engineering. Now, with respect to construction and building, these engineers get involved in different uh, building materials used, which are basically, when it's manufacturing, it uses less energy. So they're saving energy. Maybe um, you know, you see these industrial uh, areas where these smokestacks and smoke's coming out and all that. So they're trying to reduce the carbon footprint and reduce all the that are released, hazardous materials and toxins that are released in the air from these factories that are, building their products, right? So as far as the construction, there's green buildings, they're building materials. There's in the factory they're using, you know, manufactured products. One is like, instead of chopping trees down to build lumber, they're making fabricated lumber. So it's part ground up sawdust and part cement. There's what's called fiber cement boards that are used for siding, and one brand is Hardy, HARDIE. And there's other types of building products that are similar. So the environmental engineer gets involved in. There's also reclaiming, and that's kind of been prevalent now, where you go into an old building or old house and you dismantle it, and you see what kind of products can be saved and reused. So instead of like knocking down a house, an old house, okay, and just taking all the stuff to the dump, they're dismantling the house piece by piece and they're reclaiming the materials. So some of the wood can be reused. Some of your lumber can be reused. Some of your house siding can be reused. Some of their doors, right? Down to like the doorknobs, windows, and things like that. So there's companies that actually specialize in that, in buying used building materials and then reselling it. And then in some cases, there's historic properties like a historic house, and you your door got eaten by termites, so they go to this store, and maybe you might find a similar door or a doorknob. In the old days, they had those glass doorknobs, right? Um, they don't they don't necessarily make those anymore. But if it's saved from an old house that got torn down, then it's a lucky find, and then you have something that you can replace it with. And there's strict guidelines. If your property is on the state or federal historic preservation list, you can't just start knocking down things and replacing it with newer building materials. You have to kind of stick to the guidelines, right? So, um, hopefully that answered the question. I know I kind of digress, but what do you think, Martin? Was
That
that a
was
good
good.
answer?
That was good. Good environmental answer was environmental engineering. So very good. We got one last quick one. Maybe you can answer while we get some time here. It says the visitor says, I've heard the terms construction engineer and forensic engineer. Can you explain these two types of engineers?
Yeah, okay. So I have a degree in civil engineering, but I don't design bridges. Um, so I kind of converted my engineering to being a construction engineer. What that is I go to construction job sites and I manage the various projects as a construction manager. So construction engineer can get involved in uh, all these different types of engineering, uh, just as a uh, overall look seer, but not I'm not designing plans and stamping plans or anything like that. A forensic engineer could be any one of the engineers that I mentioned, and basically, you heard of that show CSI where they're investigating how the person died, and inspecting, you know, dead bodies and all that. So the forensic engineer is investigating building failures. And I do some of that too when I'm involved in some construction defect litigation cases. Um, but it goes further than that. Okay, so let's take like somebody slips and falls and gets hurt, and there's a lawsuit. That's a personal injury claim. Why did the person slip? So you bring in um, a specific engineer, or it could be me as the expert witness, and I would hire a specific engineer to do what's called a slip test. And in technical terms, it's called a coefficient of friction test. And it's like, was this floor tile too slippery on its own? And that's why the person slipped and fell, or did it get wet and it became more slippery, right? So it gets technical. There's also when we have failures such as concrete failure, the Florida building collapse, you bring in engineers to look at the corrosion factor, right? Rebar corrosion. Why did why did this piece of balcony fall down? The rebar got corroded. Was it due to water infiltration conditions? Was it due to failure of the paint and waterproofing? And if it's failure of the paint waterproofing, we have various tests that can be done. On the paint, one test is called the DFT test, dry film test, where we look at uh, the thickness of the paint. And in some cases, we have to scrape off samples of the paint, send it to a laboratory, and let them tell us what the mil thickness of the various coats of paint were. So it gets really technical. So forensic engineering is basically going deeper into determining the cause of, let's say, the water infiltration. Where did the water come from? The roof's leaking. Okay. What caused the leak? And then because of the leak, were there substantial damages to other parts of the building because of the roof leak? If it leaked into the penthouse unit and that unit got damaged and got damaged flooring and all that, yes, the roof leak caused other damages, right? So there's multiple claims and insurance companies involved. So basically, that's the difference. So Martin, we got any other final comments before we sign off?
No, that's all we have from either our Zoom or from the social media.
Okay,
Yep.
great. So on behalf of our Ask the Expert webinar series, Martin Pea, Lance Luke, we thank you for joining us. We hope you learned something, that there's different types of engineers. And stay tuned, watch our videos that we already did, webinars, and then sign up for a future webinar. It's fun for us to give it because we don't mind. We like to help people, and uh, I'm excited to talk about the railing, and hopefully it helps people. And then one of our other webinars on Sagrada Familia, because I was there in person recently. I'm excited to talk about that. I may even give a prize. So I bought this expensive keychain at the store. It's funny because it's almost like Disneyland. You go on the ride and then how do you get off the ride and then go back to where you want to go in the park, right? You got to go through that store, right? So if you um, just finish your little Dumbo ride, you enter the store and there's Dumbo stuffed animals and cartoon books and whatever. So I mean the same thing. I left, and before you exit, you've got to go to the store. So I ended up spending a couple $100, but hey, let's give away a prize next time. I think we should do that. All right, so thank you for joining. Hope to see you at the next webinar. Sign up. So see you at the next one. Thank you. Aloha.
Aloha.